So, okay, Rob, you recently announced 3D Crosspoint. I think we're all trying to see, what is it? Can you explain a little bit how it works? And then also, is it all just foils right now?
Sure. 3D Crosspoint technology is a new class of memory technology, and it takes advantage of an innovative 3D crosspoint architecture. It's a crosspoint architecture that we can stack in 3 dimensions, hence 3D crosspoint. And the essential part is this crosspoint architecture that enables us to scale to high density. But what we do is we connect between the wires. So we have think of it like it's like a window screen, a crosspoint architecture, where between where the wires cross, we put sub-microscopic pillars of material. And that material includes a switch, which allows us to connect, to access individual bits of memory or words of memory, to treat it like memory, but also a memory storage element that allows us to use it like storage at the same time. And unlike traditional DRAM memory that stores its information in electrons stored on a capacitor, or NAND memory that stores its information in electrons trapped on a floating gate, this uses a bulk material property change of the material itself to store whether it's a 0 or 1. And that enables us to scale to small dimensions. And that enables, of course, something that is a new class of memory, 1,000 times faster than NAND, so unlike NAND, with super high endurance, yet still 10 times the density of DRAM, a new class of memory.
Okay, so you've done a good job of explaining the technology. I get it, I understand it now. But you know, here I don't want to just do foils and talk about what could be. Can you talk to us a little bit about what the products are? When are they going to be announced? When are they coming out? And maybe give us a little insight.
Okay, cool. Today we're announcing a new brand for our storage products. It's called Intel Optane Technology. And Intel Optane Technology combines this innovative, revolutionary 3D crosspoint media itself together with optimized controllers that allow us to access that information, and then optimized interfaces to the platform, hardware, and then software IP to make it a complete product. And we'll be delivering Intel Optane-based SSDs to the market in 2016 across a broad variety of platforms, from the data center down to low-power ultrabooks. But also, we'll be delivering this 3D crosspoint memory technology in the form of DIMMs for system memory for our next generation Xeon platforms that give us even shorter latency access to this memory and use it like traditional system memory.
Okay, so I get it, SSDs and DIMMs. I still want to see it work. So Rob, can you show me one?
I think I can today, Brian. And today we're going to show you the world's first public demonstration of an Intel Optane-based SSD. And I have that over here. I'm going to get that started. And what you're seeing here is a benchmark comparing an early prototype of our Intel Optane-based SSD on the right compared to a traditional NAND-based SSD on the left. And not just any NAND SSD, this is our highest performance NAND-based SSD with PCIe and super high endurance, super high performance.
So one of the fastest SSDs in the world today.
One of the fastest SSDs in the world. And what you're seeing is the performance across a broad variety of real-world type workloads simulated by iometer. And what you see is different queue depths, and short queue depths that are more realistic of transaction-based workloads that we see in the market today. So things like financial services applications where they want quick transactions and they want them to be very predictable. And what you saw as we were cycling through the different workloads there was the performance advantage over the fastest NAND-based SSD in the world today is somewhere between 5 and 7 times the performance with our early prototype SSD.
So, I mean, this is amazing. 5 to 7x is, when you talk about performance, it's truly revolutionary.
It is exciting, yeah.
Yeah. So, Rob, anything else you want to talk about on this? Or,
Yeah, I would say that what we're really excited about is the application benefits of this, of course. So folks that are out there, anything that requires bigger memory, anything that requires wicked fast storage, with non-volatility will benefit from this. So things like enhanced rich media, immersive gaming, mass scale virtualization in the cloud, in-memory databases, high-performance computing. We expect to see breakthroughs in personalized medicine, for healthcare. We expect to see breakthroughs in big data analytics that enables to run companies more efficiently, as well as cities and maybe countries as well.
So thanks a lot, Rob. I know you and your team have worked tirelessly. For those in the audience who don't know it, these kinds of inventions don't come overnight. There's been 10 years of research and development to get to this point, and many years of product development. So I'm really happy and excited for what you guys are about to do.
Very excited.